Yeah.
Okay, guys, shh. Can you please find the two formulas you think that we're going to use today based off of the title? I mean, one good thing about our book is they're going in order. Please find the two formulas that we're going to use today. And what do you think, just based off of your prior knowledge of the topic, what do you think I'm going to write here? Shocking. And what do you think I'm going to write here? And what do you think I'm going to write here? Okay, now having camera issues. Okay, let's talk about these symbols and what they mean. I want to bring you back to the example that we did last week. So a week ago today, I had the four brothers. Remember the four brothers, okay? And there were 6 different possible combinations of a sample size of 2. So we listed all 6 possible combinations of 2 brothers. And then we found the sample mean of each one. And we plotted all of those sample means on a dot plot. And what did you guys notice about the center of it? You have recollection of that? You can flip back in your notebook. It was 7.1a. 7.1a. We put a like dashed line of symmetry on the dot plot. Then a whole 7 days. Talking about the first example. I know, it's okay. It is, that's important. 7.1a. You look back at your first dot plot. It is symmetric, that's not the part that's convenient because it's contrived, but. Okay, what was the whole point? So I'm trying to decipher this statement based off of that dot plot. What do these symbols mean in words? It took me 2 whole days to teach it, things that they could write in words.
But the mean of the sampling distribution is the same as the mean of the population.
Damn, nuts. Okay. The mean of the sampling distribution, which means the middle of that dot plot, we drew that line, was the mean of the population because we went back and we added those 4 brothers' heights together and divided by 4, and that happened to be the exact center. So I know it was a very contrived example. I don't know if you guys know Juno, but Juno is a very questioning human being, which I appreciate. And Juno was like, yeah, but how come it works for everything? You just use it for this one example of 4 people. And I was like, you're not wrong. But anyway, the trust. Tomorrow when I get into the central limit theorem, I'm gonna build more of your trust on that. It's not hard, I promise you, it's not hard. It just sounds great. Okay, just spoiler alert, if you want to think about it this way, what do you do to find the shape of a sampling distribution when it's proportions? Shape. Large counts condition. Okay, large counts condition says n times p is greater than or equal to 10. Well, is there a p to plug in when you're working with means? No, you don't have a percentage to plug in, so there's got to be something else for shape, and that's what the central limit theorem is for tomorrow. And it's not hard, it's just me running back and forth between the desks showing you the applet again and again. It's not, there's no, please don't, it's not fancy. It's just, anyway, okay, took me 2 days to teach you. The mean of the dot plot with all of the sample means should be, in a perfect world, equal to the population mean. That's backwards stats magic, meaning you can take your samples to make an estimate of the real population data. Okay, and then this guy, we haven't really worked with him too much yet. Standard deviation over the square root of n. And the reason is because you're like, why is it not just standard deviation? Well, if you remember, as you increase the sample size, it gets tighter and tighter together, the numbers, remember? Okay, so this is what makes it get smaller variability. So sample size goes up, that's a good thing, means the numbers get closer together, which is a good thing, meaning you can make a better estimate, which is a good thing. Okay. Get ready for many normal CDFs. Oh, how you love that. Now, notice in all of that stuff that you wrote down, you probably did not notice, maybe you did, did anybody notice, that I didn't say anything about shape. It was just Monday, so you just came in and started writing. I know, but usually when I talk about these, the first thing I talked about was shape, then I avoided the subject here on purpose because you can't do n times p because there's no p anymore. So we have to actually, I have to like show you that, which is tomorrow. Anyway, the center, the mean of the dot plot should be equal to the population mean. Is it going to be perfect if you don't have the whole dot plot? No. Do we really care? Not really. Good enough estimate. Okay, spread. What do we know we have to do first? Okay, so just really quick, this is the standard deviation of the dot plot of all of the sample means. Should be equal to the original standard deviation of the population divided by the square root of the sample size. And this is a good thing because it makes the numbers closer together, which we like. Okay, so notice I sort of kicked the can down the road. I never want you to kick the can down the road, but I did it today, meaning that I've avoided the conversation of shape altogether and just said, today we're going to do normal, which means that it's normal CDF. Okay. Did you guys write this already? Okay. The length of human pregnancies follows a distribution that is approximately normal with mean 266 days and standard deviation 16 days. Find the probability that a randomly chosen pregnant woman has a pregnancy that lasts longer than 270 days. Okay, I want to have full disclosure. This is a chapter 2 question. This is not a chapter 7 question. I could have given you this question in chapter 2. Does that make sense? Okay, the only thing that you would not have done in chapter 2 is the random variable notation, which we are going to do now. So x is greater than 270. Okay, and we know we can use normal CDF because it says normal right there. Okay, what do we do when it's greater than? Okay, take a minute, make sure you know where normal CDF is in the calculator, because if you ask me during the test, that's going to be really awkward for you. And I can sort of cheat. I don't need to label the low and the high because I put the random variable notation in the front, which gave me the inequality, which states my low and high. Okay, before I move on, any questions about A? Does that all make sense? You know where the numbers went? You know why it's 270 to positive infinity? By labeling? Okay. All right, now we're gonna get into chapter 7. I don't know. I can't do the camera today. It's just not, it's not, it's fine. Okay, now I would like to ask you, there is one thing in this problem that takes it from chapter 2 to chapter 7. What is the thing that takes it from chapter 2 to chapter 7? Chapter 2 to chapter 7. There's a number. Okay. Back in the previous problem in A, you were just taking out one woman. And for my math people out there, I would like to tell you that you're really doing chapter 7. It's just that you're putting this over the square root of 1, which doesn't really affect your answer. Do you see what I'm saying? Like, we don't write 16 over the square root of 1. Okay, now there's 6 though. And so you can't just be like 16 over the square root of 1. You have to be 16 over the square root of 6. So, okay, but that's not what it's asking right now. It's asking what the mean is. Okay, so we go to our formula sheet. And it says the mean of the sampling distribution should be equal to the mean of the population. Great. The mean of the sampling distribution should be equal to the mean of the population, which is 266 days. I think that's my favorite question of all time. That's it. Yeah. The 6 doesn't come into play until standard deviation, because the center is still going to be 266 no matter what. Okay, notice I left a chunk of space because we have 3 things to do, right? What are the 3 things we have to do? 10%, calculate, and then your favorite. Okay, but guess what, guys? You see how there's this meat down there at the bottom? See it peeking up? That's the last thing of the day already. I know. Why? Because I can't teach you anything else if you don't know how to do shape. So today's very short. Perfect for Monday. And then what's gonna happen is I'm gonna go try to find my phone because it's missing again. Yeah, yeah. There's a chance I left it in the bathroom. Let's just cross all our fingers. It's in the bathroom. Now, what I could do is play the sound from my watch and freak out anyone that's in the bathroom right now, which would be really funny, but probably not gonna do that. Okay, anyway. So calculate and interpret the standard deviation of the sampling distribution of X bar. Verify the 10% condition is met. Again, all the directions are going to say this. You need to do that first, though. So n equals 6 is less than all. Whoa, whoa, whoa. I just was so excited about being done that I wrote it all wrong. I forgot to put the actual part in there that is important. 10% of all. I still think that's true. Pretty sure there's more than 60 pregnant women. No, completely unreasonable, Mrs. Thomas. Okay. That's too much of a square root. Wow, wow. 16 over the square root of 6. 6.532. Okay. Now, let's say that your ankles were tied over a pit of hungry crocodiles. And the only way I'm sort of going with a Monty Python and the Holy Grail thing here. So the only way to release the cursed rope to allow you to free yourself from the pit of angry crocodiles is to figure out the interpretation sentence. Oh, I'm dead. Okay, you got this. Okay. What I'm saying is, you're out in the middle of the wilderness, you have nothing. Okay. Okay, I hear it. Okay, so starting with that, over many random samples of 6 pregnant women. Sweet little adorable pregnant women. What? Oh, I have to explain myself. My daughter-in-law's pregnant, and I just got her a little like a, expecting ornament for their Christmas tree, and it's super cute. It's true. It's true. Hopefully. Does it help you to know that it says 2025 on it?
Even worse. No, they're just like empty, they're nondescript, you can use them at any time.
Have you You don't have data. You guys made ornaments like in kindergarten to date on it?
No.
What?
I think they were ugly in my picture.
Ornament. Oh,
Yeah.
yes, good one.
It's not a weird thing.
I'm going on. The length of human pregnancies typically vary from the mean. I think you could have gotten that. I think you could have freed yourself from the crocodile curse. I'm just saying.
I don't think so.
You could have.
Yeah, I would forgot.
Oh, I mean, it kind of depends on how like strict the overseer was gonna be. Does anybody know the scene of which I am referring, the duck and what does
Yeah.
the duck float or sink? Yeah, not gonna happen. What? Yeah, I'm almost done.
Oh, my God.
Okay, last thing.
Okay.
Oh, yes. Was it in the bathroom? Yes. I told them as soon as I was done with the notes, I was gonna go search for it. I'm sorry, honey. How did you figure out it was mine? I'm just kidding. I'm just kidding. It's very obvious.
Your face is on there.
Yeah, I know, I know. She's so cute. See, it's me, and Mr. Talbot, the Disney World. Guys. Okay. So. How is this problem going to change from A? We did A. Where we said greater X is greater than 270. We're going to do that again. 270 to infinity, 266, 16. What's going to change? Standard deviation. It doesn't make sense that it's less spread out because you had a bigger sample size than 1. So because the sample size went from 1 to 6, that means your graph should be less variable, less spread out. Now, if I was doing this problem and I hadn't already calculated this up here, you can, in your calculator, just type 16 divided by square root 6 straight into normal CDF. It's fun. I'm going to show you what I mean. So 270, 10 to the 99, 266, 6.532. And in this one, you don't need to label anything because this takes care of the first 2 labels. And then you labeled these up here. But what I wanted to show you was, if you go to normal CDF, you can type math into normal CDF. So I know we already did this one, but if you hadn't done it, you could type 16 divided by square root of 6 directly in there and it will calculate that for you. So you can put that straight in the calculator like that, which is fun. Does it make sense that the probability is smaller for something extreme? Okay, let me show you my joke. It's great. I'm totally waiting. Oh, it's weird that that's the same as that. Okay, so X bar is at the therapist. He did the psychiatrist and he said, my ex-girlfriend thinks I'm mean and my current one thinks I'm average. And the therapist said, maybe you set your bar too high. Yeah, it's 2 puns and a joke. Right? Yeah,
We got 3 for the pencil.
it's pretty good. I like that one.
Wow. Oh, that was.
Do you have any idea how excited I was when I found this joke, by the way?
Mhm.